So we looked at the last video in the series, which is work done. So think about when you move objects. So we're moving a jet plane, we're pulling on a pulley to move a load, lifting boxes, lifting weights. What do we really mean by that? So there's this concept that we actually call work done. That's to develop an understanding today of what work done is and how you calculate it. So basic stuff, you could define a unit for work done. If you could calculate it using the equation, rearrange the work done, an equation, and using questions. And think about the idea of work done on a flat surface to work done against a gravitational field, because they're not quite the same. It's also maybe I think, when you get something like this Formula 1 car moving, the wheel has got friction obviously between the floor and the ground. You're pushing forward, you're doing work by moving it. But when you brake, where does all the energy go? Well, I think you can see the glowing brake discs. Now if that was a normal car, those brake discs would be melting, but these are carbon fibre discs, specially made so they can take the temperature. Now then, so work then, it's just basically energy transfer, and a force causes an object to move. So we've got a formula, work done, or W. Sometimes you could use just energy, I suppose, but we tend to call it work done. Is force applied times the distance moved in the direction of the force. What's crucially important to realise that no energy transfer takes place in that direction when the motion is not in the direction of the force. So you could be pushing against something and expending energy, but it doesn't apply in this case, that we don't call it work done, which is kind of confusing, but there you go. So work done is measured in joules, force is measured in newtons, and distance is always measured in meters. Simple example, push a box, 100 newtons of push force, so that way, or on the picture actually it's that way. 5 meters you move it along, and the work done will be 500 joules. That's the energy we've had to put in to move it that way. Make a note of that. Now also you can have a go at looking at the video about work. This is Eureka video, they're really good. Answer the questions down here. Finish up by defining the joule, which is basically that bit there. You could have a go at a little bit of a practical, which is here, thinking about work done. It depends what you've got at home if you're not in school. There's some consolidation questions here on the mini worksheet there, the same as the questions before. Now there are 2 videos tasks actually, there's work and there's the inclined plane. So you basically watch the 2 short videos, make notes on the key ideas, draw any images and arrows carefully. There are some nice consolidation questions there and a little bit of more explanation for you. Answers there quickly, I'll get off them. You've also got some structured questions, tells you what the marks are at the side, and it gives you a nice example for what it is. That is it, so that is the whole unit effectively done. We go right back to the top of the PowerPoint. We've covered 5 lessons in effect. So we've got contact forces, non-contact, friction, Hooke's law, resultant forces, equilibrium, work done. First half of the forces and pressure. So we've basically now, we have looked at pressure, forces, sorry, and we're going to go on in the second part to look at pressure. So we'll see how that goes. Let's get rid of this one, and we'll stop our recording.